So basically electronegativity क्या होता है? So it's a tendency of an atom in a molecule to attract the shared pair of electron towards itself. Okay, to pull the shared pair of electron towards itself. So in a group, electronegativity basically it decreases, right? And in a period, when you move from left to right, the electronegativity increases. And in a whole periodic table, fluorine is the most electronegative element. Okay, so just remember, fluorine is the most electronegative element in the whole periodic table. Yeah. Okay. So I'm giving you some order. Just keep in mind fluorine, right? Then oxygen, then chlorine, bromine. So this is basically a electronegativity order, right? अगर आपको exams में कुछ questions आते हैं, so basically they will ask you this type of question from this, like they will give you fluorine and chlorine. In between fluorine and chlorine, which one is more electronegative? Obviously, the fluorine is most electronegative element in the whole periodic table. So just learn this sequence: chlorine, then oxygen, then nitrogen, chlorine, then bromine, iodine, sulfur, then carbon, then phosphorus. Okay, so basically there are some, I have written some reactivity or some electronegativity order of some element. This is very important. Okay, and you can use the mnemonics like you can use phone, and call. You can use call, bro, right? Phone, call, bro. I and from S you can write Sanidhi, right? From I and Sanidhi, calling, pay hand, right? I and Sanidhi, I and from S you can write Sanidhi or any name, calling, pay hand, right? This is pay. Okay, तो आप ऐसे याद कर सकते हो इस चीज में. Okay, so fluorine is the most electronegative, then oxygen, then nitrogen, and so on. Okay, so just learn this sequence. This is very important. Now let's summarize the topics. We have done the physical properties, all the physical properties. So I'm just summarizing it over here. So write down the conclusion. After that, we will start with the chemical properties and its strength. Okay, so here I'm writing in a period. In a period when we go from left to right. And here I'm writing in a group when we go from top to bottom. Okay. First property. I will ask you from this property because already I have discussed. Let's see, आपको याद है या नहीं, whether you have revised or not. So in period, just tell me the trend of Z effect, whether it will increase or decrease. Yes, Aisha, tell me. What will happen when we move from left to right along a period? So what will happen to the Z effect? Will it increase or decrease?
It will increase.
Yeah, it will increase, right? And what about in group? So Z effective, it decreases. It decreases, right? Second property, right on the shielding effect. Shielding effect. So basically, shielding effect remains constant, right? But in some cases, we found that uh, shielding effect, significantly it increases, right? जितना उसे increase होना चाहिए उतना increase नहीं होता, so that means हम उसे constant मान लेते हैं, right? So you can write remains constant or doesn't increase significantly. Write down doesn't increase significantly, or you can write it remains constant. It remains. So overall, the shielding effect remains constant when you move from left to right along a period, across a period, sorry, right? And what about the group? Yes, Neha, tell me, what will happen if we move from top to bottom in a group? So what will happen to
It
the shielding
increases.
effect? Yeah, so it increases. Very good. Increase. Okay, right on the third one, atomic size. Now, Sanidhi will tell me what about the atomic size variation in period and group.
In period it decreases and in group it increases.
Yeah, very good. And in group, it increases. Now the fourth, so basically pure ionization enthalpy. The fifth one, your yeah, electron gain enthalpy. Sixth one, your metallic metallic character. Seventh one, non-metallic character. Eighth one, electronegativity. These are the general trends, right? But we will discuss it. There are some exceptions. There are some anomalous behavior of group of period number two. Okay, I will discuss it after this. So electronegativity, ninth one. Uh, First, let's discuss this. Now, just tell me, Aisha, what about the ionization enthalpy in period and group?
In a group, it decreases, and then in a period, it increases.
In a group, it decreases, and in a period, it increases.
Increase.
Good. Yeah. And what about the electron gain enthalpy? Neha, tell me.
It becomes more negative when you
Yeah,
go
you know.
left to right and less negative in the
Yeah, you
group.
can write more negative when you move from left to right in a period. Okay, and what about this? So electron gain enthalpy, it becomes less. Yes, Sunny, they tell me about the metallic character. In a period, metallic character increases or decreases.
Increases.
Increases, are you sure? In a
Sorry, ma'am.
period, just remember the periodic table. Extreme right में क्या आते हैं आपके सारे नॉन मेटल्स आते हैं राइट एक्सट्रीम राइट में सारे नॉन मेटल्स आते हैं एंड एक्सट्रीम लेफ्ट में आपके मेटल्स आते हैं तो यू आर मूविंग फ्रॉम लेफ्ट टू राइट मीन्स आप एक्सट्रीम राइट की तरफ जा रहे हो आप एक्सट्रीम राइट की तरफ जा रहे हो तो ऑब्वियसली द मेटालिक कैरेक्टर डिक्रीजेस right? Because here the non-metallic character increases. Non-metallic character increase हो रहा है when you move from left to right, and the metallic character decreases. Okay, so just remember that metallic
Okay.
character decreases because maximum metallic character, maximum the most metals are present on the extreme left of the periodic table. Okay, your alkali metals, your alkaline earth metals, right? So basically your S block elements, so they are metals and they are present on the extreme left. So metallic character obviously decreases when you move from left to right. And in a group, so obviously the metallic character increases. It increases. Okay, what about the non-metallic character? Aisha, tell me.
It will be the opposite.
Yeah, it will be the opposite. So it increases. And in a group, it decreases. And what about the electronegativity, Neha?
Increases in a period and decreases in a group.
Very good. Yeah, so almost we have covered each and everything, I think. Yeah, one more thing is there. Okay, write down the basic nature of oxide. I will discuss it in details when we cover the chemical properties. But write down here also the basic nature of oxide. Okay, when an element they form oxide, so what will be the nature? So basically, basic nature of oxides when you move from left to right in a period, what will happen? So it decreases because we know that metals क्या form करते हैं? Metals form basic oxides and non-metals form acidic oxide, right? So the metallic character it decreases, right, in a period. So obviously the basic nature of oxide also decreases. It will also decrease because non-metals form the acidic oxide and basic oxides कौन बनाते हैं? Basically your metals form the basic oxides, right? And when you're moving from the basically it depends on the metallic character, right? So metallic character is decreases when you move from left to right, so obviously the basic nature of oxide it also decreases. Okay, similarly what will happen here? So here it will increase, right? So basic nature of oxide in a group increases. Okay, similarly, write down the 10th point, acidic nature. Now it is very easy. Now Aisha, tell me what will happen to the acidic nature of oxide.
Increases in a period and decreases in a group.
Yeah, very good. Increases in a period and
So the metallic
decreases.
character is proportional to the basic nature.
Yeah, and non-metallic character is directly proportional to the acidic nature, right? Because we know that metals क्या करते हैं? Metals they form basic oxide. Non-metals form acidic oxide, right? तो आप ऐसे याद करो. And acidic in a group, it decreases. Yeah, so basically they are directly related to the metallic character for the basic nature, right? And acidic nature is directly related to the non-metallic. Okay, so is it okay? आपको ये table, this table is very very important, right? ये याद रखना. Okay, now write on the next topic, chemical properties or the periodic trends in chemical properties. Okay. So in chemical properties, we will discuss first how to write down the formula of the following pair. If the element is given and they just ask you predict the formula of the following pair of elements. So how we can write down or how we can predict the formula. Okay. So write down the first. Okay, let's see in question form where we will discuss. Write down the question. Predict the formula of the following pair of element. First question is if lithium and oxygen is given. So how you will predict the formula for lithium and oxygen? How they will combine together to give a formula? Okay, so obviously let's see lithium. So we know that lithium belongs to the group number 1, which is alkali metals, right? So it belongs to the group number 1. And I told you earlier in this chapter that the group number, the unit digit of the group number is equals to the valence electron, right? So the unit digit of the group number, so here The 1 is your valence electron. What is the valence electron in lithium? So 1. Okay, and now we know that valence is equals to valence will always will also equals to the 1. Okay, अगर यहाँ पे valence electron is equals to or more than 5 होता तो we should just subtract it from the 8. Valency is equals to 8 minus the valence electron in that case, right? But here the valence electron is less than 5, so you can write down the valency, which is equals to the valence electron. Right, now see for oxygen. Now just tell me, oxygen belongs to which group? अब आपको पता होना चाहिए ये.
The chalcogens, the 16th one.
Yeah, it's 16th group. Right, so group number is 16. So what is the valence electron? What will be the valence electron? Yes, Sanidhi?
Will it be 2?
Very good. Right, so you can see I just told you. No, valence electron I'm asking, Aisha. I'm not asking valency.
Yeah, that will be 6, and then the valency will be 2.
Yeah. So valence electron is always equals to the unit digit of the group number. मैंने आपको trick बताया था, right? So
Yeah,
valence
you
electron is
said the
6
valency
and valency, because you can see valence electron is more than 5. So you have to subtract it from 8. 8 minus 6, so it will give you 2. Okay, so that's very simple. Now it's very easy. So lithium and oxygen. So lithium की valency क्या आ गई? So it's 1 and oxygen valence is 2. Just cross multiply it, right? And you will get Li2. That's very simple. Is it clear?
Yeah, ma'am.
Yeah. Okay, so next you guys will tell me, if I give you magnesium and nitrogen. Now tell me what will be the formula for magnesium, the compound which is formed from the magnesium and nitrogen. Silicon and bromine. Nitrogen. One is your aluminium and sulfur. Yeah, just do that.
Ma'am, can you scroll up to the notes? I'll take a screenshot. No, after the table. Thank you, ma'am. And also, can you show the order of the electronegativity? Done, ma'am. Thank you.
Do this question. Yeah, tell me. It's very simple. इतना टाइम नहीं लगना चाहिए इस क्वेश्चन में.
Ma'am, is the second one Mg3 and 2?
It's Mg3 and 2. Yeah, see, magnesium, it belongs to group number 2, right? So it's group number 2, so its valence electron is 2. So valence is also equals to 2. Now for nitrogen, it belongs to group number 15, right? So valence electron is 5, right? And your valence is 8 minus 5, which is 3. Now it's very simple. Magnesium, write down the magnesium, nitrogen, write down the valence for each. It's 2 and 3. Now just cross multiply. It's Mg3 and 2. Right, so magnesium, nitride. Now for the third one, who will tell me?
Metal.
Yes,
Ma'am, SiBr4.
SiBr4.
4.
Okay, very good. It's correct. And for the fourth one,
Al2S3.
it's very simple. आप इस type के questions कर सकते हो, right? Now one more question. Let me discuss it over here. If suppose X element is given, right? And you don't know the name of that element, but atomic number is given, 71, and fluorine. Now, what is the formula of the molecule which is formed by this unknown element, which is X, and fluorine? Try to do this. Very simple. First, I will give you some hint. First, try to write down the noble gas electronic configuration. So, see, let's check. We know that helium, neon, argon, krypton, and pure xenon, right? So helium atomic number is 2, right? For neon, just a second, yeah. Yeah, 2, and suppose this is your 10, 18, right? This is your krypton 36 and your xenon 50, right? And you can write for radon also 86. So what is the nearby? You can see it's 71. Atomic number is 71. So nearby noble gas is xenon, right? तो आप इसका सबसे पहले इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखो for X 71. This is unknown. So it's xenon, which is 54. Now I just told you, I give you some hint that in which now after writing the noble gas, in which orbital the electron will goes, right? So suppose 1, 2, 3, 4, you will assign the number to these noble gas. Now check the xenon, it comes on the fifth, right? So 5 plus 1, right? तो मैंने क्या कहा था, ये जो noble gas number है, suppose it's x. Now n is equals to x plus 1. So x plus 1 is your 6. And you have to start filling from the ns, right? So n का क्या है यहाँ पे 6 है आपका, तो you have to start the filling of electron from 6s. Right, so after this xenon, the electron will go in 6s, right? 6s2. Now this, after this 4f14 and 5d1, right? Now see, these are the valence shell. These are the valence shell, right? Now what is the valence electron over here? Valence electron is 3. 2 आपका s में है, 6s में, and 1 is in your 5d, right? So what will be the valency over here? So obviously the valency will be 3. Valency will be 3. And similarly, fluorine का भी आप calculate कर सकते हो, right? So write down for the fluorine. And we know that अगर आपको पता है नहीं है फिर भी you know the valency of your group number 17 is your -1, right? Or 1 you can take. So the valency is for fluorine, the valency is 1, right? So you can write X and F. Valency of X is 3 and for fluorine it is 1. Just cross multiply it and you will get your XF3. Right? So this is your formula. Is it clear? Any doubt in this?
No, ma'am.
Yeah. If in the question unknown element is given, so just do it accordingly. Step by step अगर आप ऐसे करोगे तो you will get the answer. Written?
Yeah, ma'am.
Yeah, ma'am.
So write down the heading. This is very important. So write down the heading anomalous properties of second period elements. Now, what is anomalous? So anomalous is unusual. Unusual, or you can say the deviating property of element. जो proper regular trend follow कर रहा था, right? But some elements are there in the periodic table or in some groups that doesn't follow that trend. Okay, because we have seen that elements are arranged in such a manner, right, in a periodic table that every element with similar chemical and physical properties, they will place together in a column, right, which are known as groups. उन्हें groups में specify किया गया, उन्हें groups में place किया गया, which show the similar chemical and physical properties, right? So based on this, several properties can be defined like your electronegativity, ionization enthalpy, electron gate enthalpy, atomic radius. We have discussed that the properties follow a proper trend. Sometimes the property increase or decrease in a group, right? But some elements are there in a periodic table or in a group that sit in the first place, right? Suppose lithium, right? Suppose lithium, because we will not consider hydrogen in this, right? If we are talking about the alkali metals, means group number 1. So suppose lithium is sitting in the first place. Okay, we will not consider hydrogen because hydrogen को थोड़ा different property होता है, right? So hydrogen we will not consider. So suppose lithium is sitting in the first place. So it shows anomalous properties, different properties. It will not show the regular trend because we will talk about that size. Size, what happens? The size increases, right? Size increases and any other properties. तो जो भी ट्रेंड होता है, जो जनरल ट्रेंड हमने ये डिस्कस किया, we have discussed this trend, right? Z effective increases in a period. So basically, we will talk about the group in this, right? So group में क्या होता है? Z effective decreases, shielding effect increases, atomic size increases, and so on. But there are some elements जो first position पे हैं, जो किसी भी group में अगर first position पे वो sit कर रहे हैं, तो they show some anomalous properties, different properties, right? Unusual or irregular trend वो follow करते हैं, right? So their behavior do not match the rest of the elements which is present in the group, right? So just remember, so this is your anomalous property, different property. So we will discuss it in details, right? So the element, just remember the element that sits in the first place of the group, it doesn't match the, its behavior doesn't match with the rest of the elements which is present in the group, right? So we will talk about that. So we will see why this anomalous property occur, why it happens, right? So first reason is that due to the very small size. See, I will discuss in details. See, just remember the group number 1, right? Lithium, sodium, potassium, rubidium, cesium, and strontium, right? So see, this lithium, it sits in the first position, right? So lithium की जो properties होती है, this is very much different from all the rest members. ये जो rest members है, they just follow the general trend which we have discussed. But this lithium doesn't follow the similar trend, right? So ये इसका जो behavior होता है, it is quite different from the rest of the members, right? So that's the anomalous property. That's the anomalous property. And now let's discuss why this behavior, why anomalous property occurs, right? So आप questions की तरह लिख सकते हो. Right, just a second. Yeah. So here's a question: why do the first element in the periodic table or periodic table group show anomalies in their behavior? Right. So इस type के questions आ सकते हैं exam में. So first reason is that, see, what could be the reasons? So due to the very small size or radii, smaller size or radii, what happens? The electrostatic force of attraction between the protons, right, and the last shell electron is maximum, right? Why? Because you can see over here this is very small size, right? This is a nucleus. Lithium की बात हो रही है, right? Suppose this is a lithium, and yeah. So we know that there are 3 electrons, right? So suppose 1 electron, 2 electron, and this is your 3rd electron, right? So in the lithium, so it has a very smaller size or radius. Radius इसका बहुत ही small होता है. So what happens? The electrostatic force of attraction between this proton, right, and the last shell electron. This is very maximum, right? So ये maximum होते हैं, so due to the very small size, right? So that's the first reason. And yeah, just remember, because lithium is again a metal, right? But it forms a covalent. It is having a covalent character. इसके पास covalent character, तो जो भी form करते हैं, कोई भी compound बनाते हैं, तो they just form covalent with that element, right? बाकी जो, for example, other members like your sodium, potassium, rubidium, cesium, right? Rest of the members, they form they are ionic character. They have ionic character, right? Suppose NaCl, when sodium, it forms a bond with chlorine. So obviously this is ionic bond. So Na plus and Cl minus में ये break होगा. But lithium क्या करता है? Lithium, due to its very small size, and basically its ionization enthalpy is very, very less, right? So its ionization enthalpy is very less. So due to that, they cannot easily form the ionic compounds like the other compounds, like the other members in the same group, right? Other members क्या करते हैं? They just form the ionic compound, but the lithium, it forms a covalent compound, right? Due to less ionization enthalpy, due to very, very small size, right? And yeah, also the electron gain enthalpy is also pretty high, right? High hota hai when you compare to the rest of the members. Okay, I'm talking about the lithium. So rest of the members se agar aap compare karoge lithium ka electron gain enthalpy, so it's quite high. Okay, so a lot of energy will be needed for an electron to enter the last unfulfilled subshell, right, and to complete the structure. So that's why lithium की जो properties होती हैं, इस behavior जो होता है, it's quite different from the others. So that's why lithium forms some anomalies in their behavior. Clear?
Yeah,
Yes,
ma'am.
ma'am.
Similarly, lithium की तरह ही, there are other elements also like your lithium, which is from the group number 1, कुछ ही आपको एलिमेंट्स के नेम याद रखने हैं और कुछ ही एक्सेप्शंस याद रखने. लिथियम फ्रॉम द ग्रुप नंबर 1, बेरिलियम फ्रॉम ग्रुप नंबर 2, right? Carbon from group number 14 and fluorine from group number 17. Right? So these show some anomalous behavior. Okay, first member in each group. First member in each group. Right? So आपको ये याद रखना है. Apart from these elements, nitrogen, oxygen, and boron also show anomalous behavior. Right? बट उनके जो एक्सटेंट ऑफ एनोमली है वो ज्यादा ग्रेट अच्छे नहीं होते. राइट? तो हम बस इन्हीं 4 एलिमेंट्स के डिस्कस करते हैं. Right? So we will discuss only about these 4 elements, why they show the anomalous behavior. So we will talk about that. Right? So we will consider these 4 elements. And इससे questions भी आते हैं. Sometimes they will ask you the order. Right? What will be the order of electronegativity? What will be the order of your electron gain enthalpy? Right? तो आपको जैसा लगता है, right? जो expected value आपको लगता है, because regular train, you know that the regular train, when you move down the group, this will happen. Either it will decrease or increase, right? But there are some exceptions due to the anomalous behavior of the first member of each group. So due to that, the trend order जो होता है वो different होता है. Right? I will discuss some questions. मैंने homework में I think question भी दे रखा था. Let me check. Let me check what was the question. And maximum students ने वो question गलत किया. Just a second. Let me check what was the question. Yeah, yeah. मैंने question दिया था I think. Which I'm writing it over here. So which of the following pairs of elements would have more negative electron gain enthalpy, right? Fluorine or chlorine. So maximum students से क्या किया है? Fluorine. Was it correct? Fluorine or chlorine? Which one will be the correct? So because we have seen that regular train क्या होता है? The in a group what happens? It will be less negative. Right? So fluorine, bromine, iodine. राइट. तो अगर रेगुलर ट्रेंड अगर आप फॉलो करो तो ऑब्वियसली फ्लोरीन का क्या होगा? मोस्ट नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी होगा. राइट? बट ऐसा नहीं होता है. राइट? ड्यू टू द एक्सेप्शन केस आई जस्ट टोल्ड यू, ड्यू टू द स्मॉल साइज, राइट, ड्यू टू द एब्सेंस ऑफ d orbital, right, and there are much more reasons. So chlorine की ज्यादा होती है. Right? So the chlorine electron gain enthalpy is more negative than that of fluorine. Right? So because chlorine has, you can see, fluorine is to the right of the oxygen, right, in the same periodic table, in the same period. So it has a higher like nuclear charge. Nuclear charge ज़्यादा होगा, right, and a small size, right, because fluorine has a small size and a high nuclear charge. Just a second. So see, I just told you fluorine की क्या होगी? Fluorine has more negative electron gain enthalpy than fluorine, right? And what is the reason? Because fluorine is most electronegative element, the most electronegative element, and due to the small size of the fluorine, it causes more electron repulsion. Right? Because आप electron gain enthalpy क्या होती है? When you are putting electron in it, आप उसमें electron डाल रहे हो, right? You are adding electron. So what happens due to the small size of the fluorine? Because we know that फ्लोरीन की क्या होती है, बहुत ही स्मॉल साइज होती है, right? So due to the small size of fluorine, when you add electrons in it, so it will have electron repulsion. Electron और electron के पास repulsion होगी इन दोनों के बीच में. The new electron means the incoming electron and the old electron जो पहले से था outermost orbit. उन दोनों के बीच में electron repulsion होगी. Due to that electron repulsion, the electron gain enthalpy will be less favorable. Right, electron gain जो होगा वहां पे will be less favorable compared to the chlorine, right? Because when you add chlorine में अगर आप add करोगे electron, so what happens? So it releases more energy, right? हमने electron gain enthalpy में क्या कहा था? It will release more energy. So जितना easily वो electron accept कर लेगा, it will release more energy, right? So chlorine के केस में क्या होता है? It will release more energy on gaining an electron than fluorine. So that's why chlorine की electron gain enthalpy ज़्यादा negative होती है as compared to the fluorine. Just remember, right? This is the exception case, right? So it doesn't follow the regular trend. Okay, so in exams, don't do this mistake. Clear?
Yeah, mom.
Yeah, mom.
कुछ टॉपिक्स आपको डायरेक्ट याद भी करने हो, समटाइम्स आपको कुछ कॉन्सेप्चुअल बेसिस पे भी आपको एग्जाम्स में आंसर दे होंगे, राइट? सो जस्ट ट्राई टू रिमेम्बर सम टॉपिक्स एंड if you can't remember, just try to write down the answer by concept, right? So okay, so where we are, anomalous properties of second period elements. Let's discuss in details. Basically, the elements are arranged such a manner in the periodic table that every element with similar chemical and physical properties placed together in columns, right? And those columns are known as groups. Even though the properties follow a proper trend, and then you can write order also of either increase or decrease. In a group, in the first place, show an anomalous anomalous properties. and their behavior do not match this is not for the lithium only, right? So this is the first element of group 1 and 2, right? And from group number 13 to 17, right? So they differ in many aspects from different elements from their members, right? So the different members of the groups. So write down the first element of groups 1 and 2 and group 13 to 17. They differs in many aspects from their subsequent elements of the group. Basically, the first element of group number 1 and 2, the first element of group 1 and 2, that is, what is the first element of group 1? So it's lithium, and for group 2, it's beryllium. So lithium and beryllium, they form compounds with high covalent character. High covalent character, right? Because we know that non-metals form the covalent character type of compound. But here the lithium and beryllium, they are metals. Instead of being metal, they form high covalent character compounds, right? So that shows the anomalous property of the first element. Covalent character. Why? Due to their small, due to their small size. And yeah, second, you can see the second period elements only has 4 valence orbitals, right? 4 valence orbitals, so that is your 2s, right? 2s and 2p. 2s, 2p and 1s. So basically, second period के जो elements होते हैं, they have only 4 valence orbitals. 4 valence orbitals, 3 orbitals for the 2p section, right? And 1 orbital for the 2s, right? So they can accommodate only 8 electrons in their valence shell, right? So valence shell की बात की जाए, so basically for the p, how many? 3, and for the s, we know that only 1 orbital. 1 orbital for the s, and for the p, there are 3 orbitals, right? So in the valence shell, so basically second period elements, if you write down the electronic configuration, so you will get to know that second period elements, they have only 4 valence orbitals. And if they have 4 valence, you can see that this is for the 2s and this is for the 2p. 4 valence electrons is there. Then it can accommodate only 8 electrons, right? 2 electrons in the 2s and 1, 2, 3, 4, 5, 6, 6 in the 2p. So basically, they can accommodate only 8 electrons in their valence shell. But beyond second period के बाद, what happens? The elements have the tendency to have more than 8 electrons. Right? When you write down the electronic configuration, you will get to know that their orbitals are more than that. Right? यहाँ पे क्या है? 4 valence orbitals है, right? So they can accommodate only 8 electrons in their valence shell. But after second period, means third period, fourth period, and so on, so elements have a tendency to have more than 8 electrons, right? They have a tendency to have more than 8 electrons, and hence they make more than 4 bonds. वो 4 bonds से भी ज़्यादा बना लेते, right? 4 bonds से ज़्यादा बना लेते हैं, so that's the anomalous property of the second period, right? Second periods means they can accommodate only 8 electrons, right? So they have the tendency to form, right, only 4 bonds, not more than that. But after beyond second period, the elements have tendency to can accommodate more than 8 electrons, and वो 8 electrons से ज़्यादा accommodate कर रहे हैं, hence they can make more than 4 bonds, right? तो ये भी एक exceptional you can say behavior show करता है second period elements. Now you can write down the second period elements only has 4 valence orbitals. 2s, right? And this is s orbitals. S में कितने होते हैं orbitals? So it's s में there are only 1 orbital. And in 2p, so in p section, so how many orbitals are there? 3 orbitals. 3 orbitals. So total 4 valence orbitals are there. So if 4 valence orbitals are there, so they can accommodate only 8 electrons. Only 8 electrons in their valence shell. Right, but beyond second period, elements have to form and wanted to have and yeah, one more reason is there. So first member of your P block elements, they displays greater ability to form P pi multiple bonds, right? So basically the second period के जो भी element होते हैं, they exhibit greater tendency to form pi bond. So P pi interactions. Why? Due to their small size, right? So pi bond they can form, means double bond, triple bond. So basically they can form multiple type of bond, right? So due to their small size, the first member of your second period element, they exhibit a greater tendency to form pi bond, right? So this is again exception anomalous behavior. So the second period element may exhibit greater tendency to form pi bond. Means your p pi and p pi interactions उसमें you can see, and why? Due to their small size. Small. Yeah. Example you can write like when we
Can
talk
you
about
explain the last point again?
this point, the second period.
Yeah.
Yeah. So I said that the first member of all the your second period elements, right? So second period की जितने भी first element है, they show a greater tendency to form pi bond. You know that single bond जो होता है, this is your sigma bond, right? So basically pi bond की formation होती है उसमें. Basically they have the ability to form multiple types of bond like your pi bond means your double bond, your triple bond, and so on. For example, if we take the carbon, which is from the group number 14, right? So again, carbon is a first element of the group number 14, right? तो कार्बन अगर किसी के साथ सिमिलरली अगर उस खुद के साथ कंबाइन करता है, right? So multiple, it can form multiple bond like carbon carbon. It can form double bond also, right? Carbon carbon triple bond also, right? So they have the tendency to form the pi bond, right? So pi bond formation की उनके पास tendency होती है the second period के जो first element होते हैं, all the first element of the second period. So they have a tendency, yeah. So they have a tendency to form pi bond. Similarly, अगर आप nitrogen लेते हो, nitrogen which is from the group number 15 and it also belongs to the group period number 2. Again, nitrogen will also form and double bond and you can see यहाँ पे pi bond की formation हो रही है. Similarly, it can form triple bond also and triple bond and right. Similarly, and with another period also, and they are combining with itself. Now, अगर किसी और के साथ अगर वो combine करें like carbon and oxygen, they also form the pi bond, right? Carbon double bond oxygen and CN bond, carbon and nitrogen bond. Another example, carbon and nitrogen, triple bond, right? Nitrogen, oxygen, double bond. So they are some examples of the multiple bond formation when some elements they can combine with themselves, with itself. So they can also form the pi bond. And when they combine with other elements, so they in that case also they can form the pi bond. So basically, the main motive is to understand that the second period element they exhibit greater tendency to form pi bond, right? ये pi bond formation करते हैं due to their small size, very small size. They can form the pi bond, right? So pi bond are very strong. यहाँ पे क्या होगा? There will be the strong force of attraction between these two carbon, right? Again, there will be a strong force of attraction between these two carbons, which is having three triple bond, right? यहाँ पे क्या है? Carbon carbon triple bond. So again, they are forming the pi bond. So you have to remember the exceptional case and the anomalous behavior of the second group element, second period element, and you can say the first member of each and every group. First member of each and every group. And basically, if in exams, if they ask you, what are the reasons? Just a second. lithium register. Yeah. Suppose if in exams they ask you the reason, what is the reason behind that? So just write down some general reason. You can write this. So reasons are due to the very small size. Second reason is high electronegativity, high electronegativity, and the third one is your absence of d orbital. Absence of d subshell, right? Because they don't have a d subshell. They have only four orbitals, right? And only four orbitals, say how many electrons can be accommodated? So eight electrons, only eight maximum electrons which could be accommodated in the four orbitals are eight electrons, right? So they have not more than more subshells. Like in D subshell, there is for example, you can write there is absence of D subshell. So अगर D subshell नहीं है, so how they can only accommodate till your P subshell. So they don't have any options due to the very small size. They don't have any option. अगर incoming electrons आते हैं, तो they could be having your D subshell so that incoming electrons will goes to the D subshell. But उनके पास options ही नहीं होते, right? So due to this reason also, very small size, high electronegativity, and the absence of D subshells, they show some anomalous behavior. The group, you can say the all the members, so first element of group 1 and 2, and from group number 13 to 17, they show anomalous behavior, right? Different behavior due to this reason, very small size, high electronegativity, and the absence of D subshell. Absence of D subshell. 2 to 3 reasons are enough. You can write in this in your exam. Last point समझ में आया? Why absence of d orbitals? Due to the absence of d orbitals,
ma'am.
what happens? Electrons cannot jump to the higher energy level, right? Because अगर electrons को jump करना होगा, electrons could not jump to the higher energy orbitals, right? When when heated or any other energy supplied from the outside environment, so what will happen? वो electron jump करना चाहेगा, right? But it has no options because there is a absence of d orbitals, right? तो अगर high energy orbitals में अगर jump करना चाहे तो भी possible नहीं है, right? So that's why this is also a reason for the anomalous behavior of the first element of each. Clear?
Yeah, ma'am.
Yes, ma'am.
Any other reason अगर आप लिखना चाहो तो there are also other reasons also, like electron gain enthalpy. Electron gain enthalpy is also pretty high. So a lot of energy will be needed for an electron to enter the last unfulfilled subshell, right, and complete the structure. So that's why due to the small size, high electronegativity, absence of d subshell, high electron gain enthalpy. So these could be the reasons. So three reasons are very enough. अगर कुछ भी आता है exam से, why do the lithium or lithium shows anomalous behavior in its group, or why do the first element in the periodic table in each group shows anomalies in their behavior. So you can write down these reasons or आप इसे ही explain कर सकते हो by giving some examples and all. Okay, clear?
Yes, ma'am.
Yeah, ma'am.
Okay, I will tell you one more thing. Okay, let's talk about lithium itself. First, we will discuss about the diagonal relationship. Diagonal relationship. Yeah, so basically, your elements like lithium and beryllium. See, elements like your lithium and beryllium, they show similarity with second element. Okay, after lithium, it belongs to the group number one. It both belongs to the group period number two, right? Lithium and beryllium both belongs to the period number two. And we know that period number two में क्या है? They just show anomalous behavior, right? They show anomalous behavior. So basically, it belongs to the group number one, right? And it belongs to the group number two, and both belongs to the period number two. Period number two. So they show similarity with the second element of the next group. See, this is lithium, this is beryllium, right? So this is a group number one group number, this is group number two. This is your period number two, and this is your period number three, right? So in after lithium, sodium came, and beryllium के बाद it's magnesium, then boron and aluminium. Boron and aluminium, which is group number 5. Now see, so it has been found that that elements like this lithium, right? Lithium shows some similarity with the second element of the next group. Right, this is the next group. Also, second element क्या? That is magnesium. So lithium basically it shows a similarity. Means similarity किस चीज में? Properties में, right? So it shows similar properties just like your magnesium. Magnesium की तरह similar properties show करता है lithium. Similarly, beryllium it shows similar properties just like your aluminium. Right, this just like your aluminium. There are much more like your beryllium. बोरोन भी आपका किसके साथ करता है? सिलिकॉन के साथ. कार्बन it shows just like your phosphorus, नाइट्रोजन, सल्फर की तरह, right? बट हमें बस इन दोनों पे फोकस करना because in NCERT these two examples are given, right? So just remember these two. So this you can see this is a diagonal relations. ये कहाँ पे lie करते हैं? They are just diagonally with each other. They are diagonally aligned with each other, right? So basically, lithium and beryllium they show similarity with second element of the next group, right? That is your with magnesium and aluminium. And this similarity, this similar behavior and similarity is known as the diagonal relationship, right? So basically, diagonal relationship exists due to the identical size of ions, right? Why it happens? Due to the identical size of lithium and magnesium, and due to the identical electronegativity also, it happens, right? So what happens when we know that as we move leftward, what happens? Size increases, and also when size also increases as we move downward. Okay, मैं यहाँ पे लेफ्ट वर्ड यूज कर रही हूँ नॉट राइट वर्ड. Okay, means see what I said, as we move leftward from the right side means आप helium side से group number 18 से आप group number 1 की तरफ आ रहे हो, leftward आ रहे हो, right? मैं just opposite use कर रही हूँ because we know that period में अगर हम move करते हैं from the left to right, right, from left to right in a period, what happens? Size decreases. But I'm talking about from right to left, right? Here, what I said, as we move from right to left, what happens? Size increases, right? Size increases, and also size also increases when we move down the group, right? तो देखो, see, अगर आप इस साइड से इस साइड आ रहे हो, मैग्नीशियम से आप इस साइड आ रहे हो, तो क्या हो रहा है? साइज इंक्रीज कर रहा है, right? And we move from top to bottom, what happens, the size also increases, right? So basically, diagonal relationship exists due to the identical size of ions, right? So lithium and magnesium की sizes थोड़ी identical होती है, not exactly same. I will not tell you that exactly same होती है, but identical होती है थोड़ी बहुत. And yeah, one more reason is that yeah, diagonal relationship also arises because of the diagonal similarity of electronegativity. See, I will write down the value. See, पहले just try to understand, then I will write down the notes here. So what happens? Just like a lithium, it is very much similar to the magnesium. Uh, right, beryllium, it is similar to the aluminium. Just boron, it's similar to the silicon, right, and so on, right. So we will basically focus on these two, lithium and beryllium. In दोनों पे हम focus करेंगे, right? So basically, what happened on moving down a group? What happens on moving down a group? What happens? The atoms and ions increases in size. What happens? Size, atomic size or ionic size increases, right? And on moving from left to right in a period, size decrease होता है, right? Left to right मैं बोल रही हूँ, size decrease होता है, right? So thus on moving diagonally, why? Right? See, when we move diagonally, what happens? The size remains nearly same, right? On moving down the group, size increases, and on moving left to right in a period, size decrease over it. But thus on moving diagonally, what happens? The size remains nearly the same, remains nearly the same. See, so basically, lithium की size is 1.23 angstrom and magnesium is having 1.36 angstrom. Not this exactly same में होता है, nearly same होता है, right? So 1.23 angstrom and it's 1.36 angstrom. Now lithium ion, when we talk about the lithium ion, so it's 0.76 angstrom, and M magnesium 2 plus, it is having 0.70 angstrom, right? So see this, see the difference between the size of ions, 0.76 and 0.72, nearly same, right? Nearly same, not exactly same, it's nearly the same, right? So we can say that the lithium and magnesium का कैसा relationship होता है? So they have a diagonal relationship, means they are very much similar in their properties with each other, right? Like their density, so they show the similar properties like in density, electronegativity, polarizing power, etc. I will discuss the polarizing power in details. Polarizing power क्या होता है? So that's very important again. Okay. Now the next, write down the next one, why the diagonal relationship arises. So it is sometimes suggested that diagonal ship also arises, or diagonal relationship arises because of the similarity in electronegativity. Okay, so electronegativity की similarity की वजह से भी diagonal relationship arise होता है. Suppose the lithium key electronegativity it's 1.0, and for magnesium it's 1.2, right? So you can see there are it's quite much similar or very much near to each other. The values are, it's 1.0 and 1.2, right? So and similarly for beryllium you can write 1.5, and for aluminium it's 1.5. So in this case, the electronegativity is same for beryllium and aluminum. For boron, it's 2.0, and for silicon, it's 1.8. Right? So basically, it's a electronegativity. So you can see beryllium and aluminum also show a diagonal relationship, but in this case, sizes are not so close to each other, right? So close to each other, and like beryllium का जो size होता है, see, first point is all about the size, and the second point is all about the electronegativity. तो मैं size का यहीं पे लिख देती हूँ. So it's beryllium Be2 plus. Size is 0.45 angstrom. And for aluminium, Al3 plus, the size is about 0.535. Right. So we can't say that it is very much near to each other, right? The sizes. So beryllium and aluminium, they also show a diagonal relationship, but in this case, you can see sizes are not so close to each other, right? But the charge per unit area is nearly same. Charge per unit area, you can see the charge क्या है beryllium पे, it's 2 plus and 3 plus. For in aluminium, the charge is 3 plus, right? So due to the very you can say बहुत ही आस पास है ये, right side charge. So you can say the charge per unit area is almost same. That is, it's 2 plus and it's 3 plus. And if you write down the charge per unit area, so it's very for beryllium 2 plus, the charge per unit area is 2.36, right? And for aluminium 3 plus, the charge per unit area is 2.50. Right? So you can see यहाँ पे तो size तो it is not very much close to each other, but the charge on the beryllium per unit area is equals to 2.36, which is very much near to that of aluminium. Aluminium क्या है 2.50, and for beryllium it's 2.36. So they are very much quite you can say near to each other. So that's why they they both show the diagonal relationship. They both show the diagonal relationship. Clear?
Yeah,
Yes,
ma'am.
ma'am.
Okay. And see the lithium and magnesium. Right. So when they form the bases means जब वो hydroxide बनाएंगे. Right. When they form the hydroxides, because they both are metals. Both are metals. So when they form the hydroxides, so hydroxides क्या होंगे? Basically, they form the base. So they both forms the weak bases. They both form the weak bases. Right. Lithium and LiOH. Just a second. LiOH and your MgOH whole twice, right? Both are base because lithium and magnesium both are hard metals, right? So they are metals, you can say. So they will form the bases. These are the bases, obviously the hydroxides. So they just form the weak bases. Right, but others क्या करते हैं? Others elements of their subsequent groups, they form the strong base. They form strong base. But these two, lithium hydroxide and magnesium hydroxides, they form weak bases, right? And you can see both forms of weak bases as why they show the diagonal relationship. Like means they show the similarity. There are much more similarity between these two, lithium and magnesium. Right? Similarity किस चीजों में? Electronegativity same है, density same है, right? You can see the almost the ions के sizes same है, right? Electronegativity same and much more, right? So we will not discuss in details. Basically, you just have to remember which metals show the diagonal relationship. Lithium magnesium के साथ show करता है, right? Beryllium aluminium के साथ show करता है. बोरोन सिलिकॉन के साथ शो करता है and so on. carbon, phosphorus, nitrogen, sulfur, etc. Right? But we will not focus on that. Just we will focus on these two: lithium with magnesium and beryllium with aluminium. Clear?
Yes, ma'am.
Okay. You can write elements like lithium and beryllium show similarity with second element of the next group, that is with magnesium and aluminium, and this similarity is known as diagonal relationship. And diagonal relationship exists due to identical sign of ions. Is it clear?
Yes,
Yeah,
ma'am.
ma'am.
Okay. Now I think the time is up. I have to discuss about the oxidation state and oxidation number. Okay, no problem. We will discuss in the next class. I think one more class. And please just do the questions of NCRT. Please try to solve all the questions from the NCRT. And if there is any doubt, just ask me.
Okay, ma'am.
3 more minutes are left. So first, let's discuss the anomalous behavior of lithium in details. See, we know that lithium atomic number is 3. So it's 1s2 and 2s1, right? So you can see here, one electron is in 2s subshell, right? So it should behave like alkali metals. जो हमने alkali metals की general electronic configuration and valency देखी थी, तो इससे मैच हो रही है, राइट? सो इट शुड बिहेव लाइक अ अल्कली मेटल्स, बट ऐसा होता नहीं है. बट दिस एलिमेंट फॉर्म्स अ कोवैलेंट बॉन्ड. Why? Due to the high polarization power, right? So here comes our polarization power. Polarization. So you can write one electron in 2s shell. So it should. Oh, let me just a second. Let me first understand this. On my next class, I will give you notes. Now let's understand what is polarization power. Polarization power. Right. So see, polarization power, polarization, right? So it's the ability of a cation to distort the electron cloud of an anion, right? So what happens? Polarization is basically, suppose this is your cation, and this is your anion, right? This is your anion, negatively charged body, and this is your cation, positively charged body, right? Now what happens? The polarization power को हम कैसे define करते हैं? So is the ability of a cation. What happens? The cation will because there is an electron, this is the anion particles, so there will be electron clouds all over all over its anion, right? यहाँ पे क्या होगा, electrons की clouds होंगे, there will be electron clouds. So this is the positively charged particles, cations is there, so it has the ability to distort. What happens, it will distort its structure, anions के structure को, spherical structure को ये distort करेगा, right? So that's ability of a cation to distort the electron cloud of an anion is known as polarization power, right? Now polarization power जो होता है, polarization power basically is directly proportional to the charge on cation. Charge on cation, जितना ज़्यादा charge होगा उतना ज़्यादा polarization power होगा. If the charge is 2 plus, if the charge is 3 plus, so 3 plus में ज़्यादा होगा as compared to the 2 plus, right? And the polarization power is basically inversely proportional to the size of cation, right? Size of cation. So smaller the cation, the higher will be, you can write polarization power, right? Basically, polarization power is directly proportional to the charge on cation and inversely proportional to the size. Size, or you can write on the radius, right? So basically, what is polarization power? Polarization power is equal to charge upon radius ratio. Radius and its size you can write. So this polarization power is the charge upon radius ratio, right? So when a cation, what happens? When a cation, see the structure. This is your cation, this is your anion. So when a cation approaches an anion, right? So what will happen? The positive charge of the cation attracts a negative cloud. यहाँ पे क्या है? There will be negative clouds all over the around the anion, right? So what will happen if the cation tries to approach the anion? The positive charge of the cation, it attracts the negative cloud, right? It tries to attract the negative cloud of the anion. So this attraction can distort, right? ये क्या करेगा cation, क्योंकि attract कर रहा है, तो so this attraction can distort, or distort means deform कर सकता है. It can deform the spherical shape of the anion's electron cloud, right? Which pulls all the electron towards itself. ये cation क्या करता है? Cation क्या करता है? It just pulls, or it deforms the spherical shape of the anion's electron cloud, and it pulls the electron towards itself, right? ये अपनी तरफ electron को pull करता है, right? So that's the polarization power. Just remember that polarization power is directly proportional to the charge on cation and inversely proportional to the size of the cation, right? Inversely proportional to the size of the cation. Clear?
Yeah, ma'am.
Yes,
Yeah, there's another rule. Just a second, I have another place. Let me check. Okay, we can continue. The student has more time. आपकी कोई another classes तो नहीं है अभी?
No.
Okay. Yeah, so there is another rule, Fajan's rule. There is a rule known as Fajan's rule. So Fajan's rule basically tells us about the covalent character in an ionic compound, right? Ionic compound में there are some covalent character also, right? So basically Fajan's rule क्या कहता है? So it tells us about covalent character in an ionic compound. And this rule is basically based on the